So let's take the example of an object on an inclined plane. We can change this angle and see when the object will start moving. So the initial velocity of the object is 0 and the gravitational acceleration is 9.8 meter per second square. And suppose the mass is 2 kilograms and the coefficient of static friction 0.4 and that of kinetic friction 0.2. So let's find the critical angle at which the object will start sliding. So at the verge of moving, the static frictional force will be maximum. So these are the y and the x directions. So by applying Newton's law in each direction, you can see that the normal force is equal to mg cosine theta and mg sine theta is equal to Fs max, which is equal to mu s mg cosine theta. And so at the verge of slipping, tan theta is equal to mu s. So the critical angle before the block starts sliding is equal to tan inverse mu s. In the case of mu s equal to 0.4, the critical angle is approximately equal to 21.8 degrees. So at 10 degrees, the block will remain stationary. But if we increase the angle above 21.8 degrees, such as 30 degrees, it will start sliding. So if mu s is less and is 0.3, then the critical angle is 16.7 degrees. At 0.4, as we calculated, is 21.8 degrees. And these are the values at 0.5 and 0.6. So as you can see, the critical angle depends only on the coefficient of static friction and does not depend on the mass of the object, because as we increase the mass, both the driving force, which is gravity, and the resisting force, which is friction, will scale in the same way with mass, and it will cancel out. So suppose theta is equal to the critical angle of 21.8 degrees, then even if we have a heavier mass, it will still remain stationary at the same critical angle and start moving above this angle, just like the lighter mass.